What's up? This is Dr. Corey Glenn, and in this video, I'm going to show something that I've had a lot of requests for, and that's how I make my stackable guides. And I'm going to demonstrate the video utilizing the components that I designed personally that allow you to do the magnetically retained guide. I found these to be extremely stable. They're low profile. They work great for metal printing or for resin printing. So if you're interested in learning about it, stick around, and these files will be available for purchase on my website at coryglenn.org. Okay, so in the interest of time, I've already got a case pulled up here that have implants planned, and it's going to be a continuation of the video that immediately precedes this one, which was on the bone reduction templates and the prosthetic spacers. So if you're wanting to know how I got to the point of having guides and everything, watch that video. This is primarily going to focus on doing the stackable components and how I do that workflow. All right, so just to get you reoriented, here's our case. We're going to be doing these lower four implants, kind of an all-on-X configuration. Just a quick review from the previous video. I brought in this prosthetic spacer. I aligned it to the occlusal plane, and this was a 14 millimeter prosthetic space from here to here. And so when that's aligned to the ideal teeth of the occlusal plane, you know that your implants need to go at least down to that level. All right. And so utilizing that, if I turn off these files, we were able to go ahead and make a bone reduction guide. And so again, this could be buckle only, this could be scallop guide, this could just occlude on the ridge right here with no lingual, or it could be all the way around. It doesn't really matter for purposes of what I'm going to be showing you here. But we've got this reduction guide, and so when that gets used, that will end up reducing the mandible down to this contour. All right, and now you're left with the dilemma of how do you make a surgical guide that you can put on to do the implant placement and your osteotomies. All right, so one option that I've demoed in other videos is you could just make swappable guides, right? You could export the tubes, just connect the tubes to a duplicate of this, and then just do a simple swappable guide approach. So that's one option. Now your other option is to go the route of making a stackable guide. All right, so we would have a stackable drill guide that would guide our osteotomies and allow us to place the implants. But one of the nice things about stackable, I don't really find it to be that much of a difficulty to just swap out a reduction guide with a drill guide. But one of the things that is more difficult is if you start doing immediate load prosthetics. All right, so in this scenario, here I've already designed a prosthetic ahead of time, and it's got passive pickup holes, but obviously if you're going to have the room for your tissue, that thing has got to be oriented up off of the bone, in this case about 2.5 millimeters. That gives space for the tissue and for your multi-unit and all that. And so you've got to find a way to orient this up off the bone. And I've found that is more difficult oftentimes to just do a swappable approach. You could also, connect it to this reduction guide, but it's much more difficult to do that portion of it. And that's kind of one of the nice things of a stackable drill guide or a stackable guide system. And then one other thing I'll show you, if you're looking for a way to initially position this, you might want to create like a tooth guide. All right, and so here I have created just a regular old tooth supported guide on the intraoral scan. And this would allow you, in this case, since these teeth are going to be in the way, this guide will not seat until after you've flapped and removed these molars. But you could leave the other teeth in place and then stack this guide to this, and that gives you a tooth support where you can know you're really accurately positioning this, pin it in place, and then extract your remaining teeth and reduce the bone down to that level. All right, so that's what I'm going to be showing. Now, you technically could do this in Blue Sky. As shown in the previous video, there are Boolean functions, which is something you're going to need. However, I'm going to demo this in Mesh Mixer because there's a couple little features that I find really useful in this stackable workflow that really speed things up for me. It's up to you. Do it however you want to do it, but that's the route I'm going to go here. Okay, so first thing I'm going to need is to export my guide tubes. All right. I have gone ahead and made these guide tube wall thicknesses be about 1 millimeter thick. You'll find that setting in Tools, Preferences, and right here, Software Guide Tube Wall Thickness. So I've already done that, and I want to set this up for the Blue Sky Fully Guided Keyless Kit, but I don't want to use the metal sleeve. So I'll usually change my hole diameter to 5.1. Height wise, the longer the better. And so if I can go up to 5 without impinging into bone, and it does look like I am just a hair right there, but we'll trim that one individual tube. And then for your offset, you're going to go 8.5 because the Blue Sky kit is designed to work with an 8.5 millimeter offset. So now that that's done, actually I don't have any impingement. So I don't want to have to punch that in for all of these individually. So if I just simply unlock all of my tubes and then just have the remaining implant tubes visible, I can now go back to this one that I changed the settings on right here and just say apply it to all of them. And you can see it very quickly applies to everything. So what I'm going to do here is go ahead and export this reduction guide as well as these guide tubes. Now additionally, if you'll remember, I've got this little tooth guide that I made already in Blue Sky Plan, so I'm going to export that, and I'm going to export this temporary hybrid, which was just designed in the denture module, and then I Boolean subtracted some 5 millimeter abutments above that. So let's go ahead and export both of those. All right, and so as I mentioned, I'm going to go ahead and do this in Mesh Mixer. So as you see here, here's the first set of things that I exported, and I exported them all together, so I'm going to just break these apart. So using the select tool, I'm going to just click on each of these. E is the hotkey for expand to everything connected to that selection, and now I'm going to hit Y, which is the hotkey for separate. All right, and I'm going to just, to keep myself organized, name this guide tubes. All right, and now I'm going to do the same thing with the reduction guide, E, Y, and I'm going to name it reduction guide, which means that this is my reduced mandible. All right, and then we'll go ahead and pull in also the temp hybrid and that tooth guide. We're not going to use them just yet, but we'll go ahead and bring them in. All right, so here's my first step is, when you look at these stackable guides, the first thing is that all of these tubes are going to be joined together. So I'm going to start by basically making this an implant tube bar. I'll connect all those together. And so we can do that, and this is one of the features that makes Mesh Mixer really nice for this. All right. Uh, Now this is not that intuitive, but the first step that I'm going to do, you notice when you export these from Blue Sky Plan or really most CAD programs, they're going to have the most precise geometry, having these really elongated triangles, and that's great, but it's not as conducive to this step that I'm going to show you right here. And so what I would like to do is basically get an equilateral triangle mesh on all of these. You can do that by remeshing, but a simpler way is simply go to Edit, Make Solid, and you see when you make solid, like your quality really ends up degrading, and I don't want that. So change your solid type before you accept it to sharp edge preservation, and let's go to the maximum solid accuracy and update it. All right, and now you see that that's got all of those really clean, crisp edges, and this is the type of mesh that I was going for. So I'm going to accept that. All right, so now that I've done that, I need to build these connections in between. And again, this is one thing that I just can't really do in Blue Sky Plan. And it doesn't make sense to build these kind of features into Blue Sky, so I'm just using it in Mesh Mixer. So what you can do is you could select this and go to Edit Tube Handle, and it simply builds a connection in between those. Now that would not have worked as well if I had done that on the original tubes. So just to demo that, you'll see here, it's harder to make these selections because of the way those triangles are configured. And then when you do it, you end up getting kind of this funky mesh. And so that's why I did that step. All right, so I'm going to just delete that. These are my guide tubes. All right, now, depending on how picky you want to be with this, you could do exactly what I just showed. Here, edit, tube handle. All right, but that's a little clunky looking. I like it to look cleaner. And so what I could do is try to get right to the edge here. But do you notice how my select tool, as I try to get a clean, continuous contour here, it wants to roll over that edge. So this is a little trick in Mesh Mixer you can do. You've got this thing called the crease angle threshold down here at the bottom of your select tool. What that does is that's going to let me select, but you see how it won't roll over that edge? So I can be really quick about swiping down here, knowing that I won't roll over the edge, and then swiping very quickly down here. Lets me get an equal selection on both of them, and then I can go to tube handle. And that to me looks like a much better connection. All right. Alternatively, if you're really being picky, you could hit B on your keyboard, which is smooth the boundary of that selection, and then do your tube handle. And that just makes it that much cleaner. All right, so that's how I do it. Up to you how picky you want to get with this. But now I'm going to just repeat between each set of guide tubes. So I try to get these tubes where I'm looking down the barrel of them and they're both somewhat even. Smooth it, and then add a tube handle. Alright, so now we've got this guide tube bar essentially, so I just rename it that. Something that would be wise to do is save your Mesh Mixer case. So I'm going to go to Save As, and just in the same folder here, I'm going to name it Stackable Project. Because the last thing you want to do is do all this work, something crashes, and you lose that. So now that I've done that, every time I make a change, I can very quickly on the keyboard hit Control S, and it just saves it instantaneously. That way, if something crashes, I haven't lost anything. All right, so now we've got this guide tube bar, but here again, it's floating up above the mandible, and that's really not what I'm after. So we've got to now create some way to stack that onto this base reduction guide. And so this is where the parts come in that I've pre-designed. I'm going to go ahead and bring those in. And so these are labeled stacking parts, and it's one STL file, but it's going to have several items in it. All right, so this is what they're going to look like when you bring these in. Now, it may not make sense to you why I've got them like this, but let me just orient you to what you're seeing here. This set is with the male-female component, and then the magnets on this well, and so this would be your upper and your lower. Disregard for a second these cylinders sticking out, because that's not going to make sense for another minute. All right, so that's usually my go-to in the vast majority of cases, is I want a male-female peg that eliminates any lateral movement and it will sock in there, but then the magnets are going to provide the retention of the base guide to the stacking component, whatever it is. All right, if you look at this component, this is just a male-female peg. All right, so there's certain scenarios where I might just need, one peg in a isolated area. I can use that here. You've also got just an isolated magnet well, so upper, lower magnet well. And then this component, which I don't use very often, but this is male female peg, and then a magnet component in between them. All right, so that's what you're seeing there, but just to keep things simple, what I'm going to do for right now is just use these, and I'm going to delete the others. Because once you know how to use this one, you'll understand how to use all the others. All right, so I'm gonna duplicate this real quick and just show you what these look like. So again, disregard these for just a moment. And if I move this component up, you can see there's your male-female component, so it's kind of got a socket it's going into, and then this would be a well for a 3mm magnet, and this would be a well for a 3mm magnet. Okay, so we need to position those. Now, I always like to position these things with the peg component on the upper stacking part. Or if you're in the maxilla, I guess it would be oriented like this. But right now, the way these things are oriented is for the maxilla, and we're doing mandible. So you can you can orient yourself by looking at this, and you want this little peg facing apically on whatever arch you're working on. Okay, so I'm going to hide this mandible. We want to transform this, so T for transform. And what I would like to do is pull this thing over and get it more or less in line with my plane of reduction. All right, and I'm going to usually I'll get one of these set up perfectly like I want it in the anterior, and then I'll do additional ones. All right, so when you're positioning these, you want to pull them where they're slightly impinging into the reduction guide. All right, I could even go a little bit more. You want them more or less flat to your plane of reduction. So you see here's the plane of reduction, and the slot between the upper and lower components is more or less parallel to that. I could spin it just a little bit. And then when you look from the lingual, again, you see how this is not flat to the plane of reduction, so I'm going to bring it up. That now looks parallel, but I want to bring this thing down. Now don't bring it all the way down into the space between the upper and lower. All right, bring it to where you've got just a little bit of the lower component poking through, and that's going to make your life simpler. All right, so this one I feel like I've aligned perfectly, and I'm good to go with that. And now, probably the most important thing about doing this is at this point, I need to go ahead and duplicate this, but I've got to keep it totally parallel. So I just duplicated it. It's sitting right under that current one. And now I'm going to hit T for transform. And I can bodily move this thing all I want. I can spin it on this Z-axis all I want. All right. And as long as I do that, then these things are perfectly parallel, as you can see right here. What I absolutely cannot do, though, is this. All right, once I do that, you can imagine that male-female component, they're not going to have a path of draw with one another. So I can't do that. I can't spin this green arrow or this the red one. Just bodily movement. So the way this is oriented right now, I've actually got the peg facing back, and usually I like to do the peg facing forward. So I'll do that. And again, I can spin it on this Z-axis all I want without messing anything up. All right. And now I probably need to do, since I've got a pin right in the middle, I'll probably do 4. So 1, 2, 3, 4. If I had, let's say, 4 pins and we had 2 of them right here instead of 1 in the middle, then oftentimes I'll just do a single one of these in the middle and then 1 on the back each side. But now we need to pull this one over here, so I need to duplicate it again, edit, duplicate, T for transform, and on the posterior, I like the peg to face back. So I'm going to pull this back, and you don't need to go any farther than your distalmost implant. All right. Now, as it starts tapering up, like you're seeing there, that can make it a little bit screwy, and so I'm going to pull that over just a bit, because again, this is what I want to avoid. I don't want my reduction guide poking through right there. Okay, so that took care of that. And then I'm going to do the exact same thing over on the other side. Edit, duplicate, T for transform, and I'm going to face the peg backward. And I assume I'll probably have to orient this one very similar to how I did that one. So I'm going to come anteriorly with it. I can actually touch that pin tube as long as, again, I'm not covering up any of my platform here. And I can't obviously impinge into this pinhole. So let's look and make sure this will work. And again, I can see I need to spin this just a little bit, and I'm probably going to have to bring it up slightly. Right there. Okay. So even though this is sitting just a bit higher, you'll obviously be able to tell that this is the level you're reducing to. Okay. So now we've got all four of those. Save your case, all right, or Control S. So that way, if something gets messed up, we're not gonna be in trouble. All right, so now I've got four individual of those stacking parts. Again, all kept parallel, and they're all positioned where I want them now. So what I'm going to do is in the objects browser, I'm going to just Control select all four of those, combine them, and now it's kind of where the magic happens. We can start breaking these things apart, and you can see the beauty of how this stuff works. All right, so I told you to ignore early on these big cylinder thingies. So now is when they're going to show their value. So I'm going to click on each of them, and when I hit E, that's expanded connected, and so it's selecting that, because even though they're all saved as one STL, they're different surfaces, and so they're not really technically touching one another from the software's perspective. So if you did four of these, you should have 8 objects here highlighted. All right. Once they're all highlighted, hit Y. That is separate. Or alternatively, you could go up under that edit menu and hit separate here. But there it shows the hotkey. All right. So now I've got those. Now, what is the point of those? We'll have to break these apart to make sense. So I'm going to rename the stuff I just separated as clean out. And now we're going to break apart the upper components. So selected them all, E, and then Y to separate. These are my top stack components, which would make all that remains here be the bottom stack components. All right. So I think you'll hopefully be able to see here why this matters. Let's just hide the top ones for a second. All right. Do you see how, with the way these things are impinging into one another, we've got part of the reduction guide poking through into here. And, you know, I don't want to have to go around manually and delete that or clean it out or any of that kind of stuff. All right, if I didn't do something with it and I left that, that's going to mean that your male-female component won't go to place and your magnet won't be able to fit into place. So what is the purpose of that other thing that I called clean out? Those are pre-oriented to this so that if I simply now take this reduction guide and Boolean subtract these, that's going to clean out any of those interferences where there might be impingement. Okay, so to do a Boolean in Mesh Mixer, select the object you want to subtract from first, in this case the reduction guide, and then you want to hold Control and select the item that you want to subtract from it. And when you do that, this pops up, hit Boolean difference, we'll accept it, and you will see that I've got this little floating bit that's left because that one wasn't touching anywhere. So whenever that's the case, it's going to just flip it inside out. That's all right. Just I'm going to select all this and then invert, which selects that piece, and delete it. But now hopefully you can see that all of those areas where there were impingements, those have now been cleared out. So that when I put back on these bottom stackable components, notice whereas that reduction guide had been poking through, it's not anymore. All right. So now this gets pretty easy. These are our lower stackable components, and we want to join those permanently to the reduction guide. So that's called a Boolean union. So I'm going to select the reduction guide and then all of my bottom stacking components and do a Boolean union. You'll know it's successful when you see that orange and purple. We'll accept it. Alright, I'm going to just make it all one color so it's easy to keep track of this stuff. And now we could join the upper stackable components to the bar. But this is a very important step that I don't want you to skip. Remember, you might be attaching these upper components to multiple things, to the guide tube bar, also to an initial tooth supported guide for placing it, maybe to a prosthesis. So once you've joined these to that, you can't really get them back. So what I want to do right now before I do anything else is export these as their own surface, and I'm going to call these all my top stacking components. And that way I've got those if I need to rejoin them to something else later on. Alright, so we've got those saved. We can always get those back if we need to. Your other alternative is you could just, go ahead and duplicate it. So I need a set of these to join to this. I need a set to join to the hybrid and a set to join to the tooth guide. So I could just duplicate it twice. And that way I've got a couple of copies of this available to me. And so we'll just hide those duplicates for right now. Okay, so I need to join these. All right, I can't do this little trick I showed you earlier, which is how I'll join these. I can't just select here and here because these are not all part of the same STL right now. What I'll have to do is in the objects browser, I've got my bar and then a set of those upper stackable components. Here, none of them are touching, so a Boolean doesn't help you. You can just simply say combine. And now I'm going to begin joining them up. All right, so we've got 4 implants and 4 attachments. I think it makes sense to simply join them, each tube to each stackable component. So we could go right here. Remember, I do have that crease angle threshold thing turned on. And I don't have to go all the way to the bottom on this, right? Because I don't want that right against the bone. And if you didn't fully trim the bone right, it might cause it to not fully seat. So I'll just tube handle that. And I'll time lapse this, but now I'm going to repeat on the remaining 4. Alright, so that now completes our stackable drill guide. Again, I'm going to make it all one color, and you can see here, that's how this would stack together. So when you would do this, you would just bond in all your magnets into the magnet wells, and then print this out of the material of your choice. I prefer metal. You can do resin if you want. It's just probably wise if you use resin to make a couple of them in case something breaks, because obviously I'm not making these super thick. Alright, so that completes the drill guide. And I'm going to name this file drill guide. But now I've also got these other components. Alright, I've got this tooth supported guide. And remember how we duplicated these? I'm going to just repeat the process with these. Combine. And again, I will time lapse this just so that you're not sitting here waiting on me. Okay, so actually you can see the way I did that, I wasn't really thinking about how straight down it's got to come. So that's actually a good opportunity for me to just demonstrate something else. Alright, your other alternative is you could just say edit, add a tube, and that feature lets you just simply position each end of this tube. You'll notice there's a red dot on each end, and I can simply position it to connect whatever two things I want. I can make the radius be different things. I'm going to just make this a 1.5 radius, which means a 3mm tube, and I'm going to connect back here just so I don't have to worry about this building down into my magnet well. Alright, and now I'll repeat that with the remainder. Okay, so now you have something that you could, once you extracted those molars where this thing can seat, since I've got it coming over the occlusal aspect, you could have this pre-assembled. You've got magnets in this component, and this is just printed resin, and that makes sure that as you seat this, everything, you know for sure it is all the way seated, because you're going to see the teeth completely indexed in these windows here. And if it's not fully indexed, you're not seated. Once it is, now you know this reduction guide's perfectly positioned. You can drill your pinholes. Okay? So now we've got this, and this is our, we'll call this our positioning guide. And that would leave your last thing, which would be your stackable hybrid. And so once again, we've got the extra stacking parts, so we're going to combine those. And once again, now we're just going to connect everything together. So we could either use the selection and then tube handle, or once again, we could just do the add tube feature. I'm going to do that just because when you do these, the idea is after you've stacked this and you've picked up your cylinders, you want something that's pretty small and easy to cut off. These are just a positioning mechanism. So by using the add tube feature, it'll just be a small connection that we can break off once the pickup is done. So exactly like I did previously, I'll take each of these dots and just connect them. So now you can see the end result. We've got our reduced mandible here. This is our stackable temp. We've got a stackable positioning guide, the tooth supported guide, and then we've got our base level reduction guide. And again, you're almost always going to put these attachments on the buckle, so it really doesn't change things whether you make your guide buckle only, whether it rolls a little bit onto the occlusal, or if it goes all the way around the mandible or the maxilla, whichever one you're doing. But it's the exact same process if you are going to do this on the maxilla. It's just that you'll flip these parts vertically. If you remember the little peg that's sticking downward, that needs to face apically. So if you're doing this on the maxilla, you would do it 180 degrees from what I have here. But you can see now how all of this stacks together. You've got four of these male-female pegs, so there's zero possibility that you can get any lateral movement on any of these guides. You've got the wells for the magnets, and so this particular part, and really all these parts, I've designed to work with one particular magnet, and I get those from Apex Magnets online. And here are the actual magnets that I've designed this for. It's a small 3mm by 3mm cylinder magnet. They're neodymium. You do need to be aware that with any neodymium magnet, if you were to, let's say, assemble these guides, put your magnets in, they're bonded in place, and now you sterilize it, that heat is going to really decrease the effectiveness of the magnets. So I would recommend you either sterilize before bonding them in or just use cold sterile. That's what I would personally do. But you can see these are really affordable. It's like $11 for 50 of them. But do bear in mind when you look at this, you're going to use so four for the bottom component, four for the hybrid, four for the positioning jig, and then four for the drill guide. So that would be 16 total. But again, that's such a minimal cost when you're looking at the price of these. You know, you're spending $2, $3 in magnets. And the reason that I used this particular one, you could resize these parts for any particular magnet you want. If you want more or less, grab. But the reason I chose this one is because when I looked through at their size versus the pull force per magnet, these seem to have the biggest bang for the buck as far as lots of strength and being really small, because we want the guides to be as low profile as possible. So if you think about it, in our case, we've got four sets of magnets, so that's 8 magnets times 1.4, you're at almost 12 pounds of retention between any two of these guides, which is excellent. You know, again, all that's providing is retention. You don't need it to stabilize it, because that's what the male-female pins are for. So anyway, if you want to purchase these components, they're on my website at coryglenn.org. If you want to design your own, you can. But this is how I basically assemble all this, and now I would 3D print this in metal. I personally like to have the reduction guide and the drill guide in metal, and then I'll do the positioning jig and this temp in resin, just on a resin 3D printer. If you're wanting a good source for metal 3D printing, there's two that I use routinely. If I'm doing chrome cobalt, I usually use Oral Arts Laboratory in Huntsville, Alabama. They do an excellent job, and for a little additional fee, they will electro polish it. So chrome cobalt is insanely strong, even in super thin dimensions. You could even make the profile of this be 2 millimeters thick if you wanted. Insanely strong, and these things, you know, when you're metal printing, you just need to make sure that you don't have any parts that are less than half a millimeter thick, because below that, metal printers are going to struggle to print that. Okay, so just keep everything thicker than half a millimeter and you should be good. The accuracy is amazing. I do generally try to keep just a standard drill, like not a implant drill, just a standard drill of the same size as my holes, or a reamer. You can buy reamers on Amazon. But you know, if this is a 2.3 hole for my pins, I keep a 2.3 reamer or a drill that I'm going to run through, just so that if there is any little burr or something in there that or a support that was missed, you can clear that out and not risk chipping up and dulling your drills if you're metal printing. The other source I would suggest for metal printing, if you want to do titanium, I would use Avident, which is the digital denture company. Anytime I do titanium, that's who I'm going to use for that. Uh, a lot of labs are going to print one or the other, so they'll either do titanium or chrome cobalt because it's a big ordeal to change out materials and everything, and there's certain additional regulations to do titanium because it's combustible. But same thing, keep your profiles to at least half a millimeter thick if you're going to metal print these, and Avident or Oral Arts are an excellent source to do your metal printing, and they're both going to be insanely strong. One advantage to titanium is you can anodize it. So let's say if you wanted to color code your implant tubes different colors, just so that visually you could do that. Chrome cobalt's going to be a little stronger, and it also has the ability to be electro polished, whereas the titanium, if I polish it, which I usually don't, I usually am going to have to do that manually. But anyway, that's how I do this. And again, if you want to purchase the parts, go to the website; they're available. And hopefully, you found this useful. Thanks.